Thank you very much. It's an absolute delight to be here today. Thank you very much to the American Society of Mechanical Engineers. I think this it's a very exciting area for engineers. What are marine renewables? And this is half the difficulty, I guess you could say, is that there's actually quite a few different types of marine renewables. So this is a quick education in marine renewables and the different types that there are. I mentioned wind energy, and offshore wind energy is considered to be one of these marine renewables. What you see over on the right here is a conventional offshore wind farm. Why do they go offshore? Well, firstly, there's a lack of space, particularly in Europe, to do the big projects that are required. There are projects, 1 gigawatt, 1,000 megawatt projects proposed east of London in the North Sea. And there aren't that many places in the UK where you can do that kind of size of project on land. But also the wind speeds are much greater offshore. And again, it's driving innovation. On the left here, what you see actually here is an illustration of a floating wind turbine being developed by Norsk Hydro, which may or may not come through to fruition, but it's quite interesting to see how these things develop. And I think the common thing here is that many of the issues that we face, many of the legislative issues, are common to all of these technologies in terms of permitting and the route through environmental consenting. Take wave energy. What is wave energy? Well, it's not to be confused with tidal energy. The two are both wet and salty, but they're very different energy resources. Wave energy is created by the action of wind across the sea. And it's the time average transfer of energy from the wind to the sea that creates the waves. And typically, the sort of waves that contain all of the energy, the deep swell waves, have kind of periods between wave crests. You're looking at somewhere between 80 and 150 meters between those wave crests, and time periods between those wave crests of anywhere from sort of 8 to 15 seconds. So it's those deep swell waves that contain the energy. And in order to create those waves, you need the fetch of the ocean, which is what this right-hand picture here shows. It's that sustained action that forms firstly little riplets, and then the progressively larger swell waves. And those waves can travel for many thousands of miles across the ocean without losing energy. And it makes it a very concentrated form of renewable energy. So ultimately it comes from the sun. The sun drives the wind drives the waves. Tidal energy, on the other hand, comes from the moon. Lunar energy, you could say. And it's the gravitational pull of the moon in combination with the sun that gives rise to the tides. And it's the differences in sea height that drives the flow of water between locations. And tidal energy concepts are all about harnessing the flow of water from those different locations. And typically what you need for a good tidal location is a constricted area where you've got water pouring from one place to another. A couple of other types of energy here, which I'm not going to cover in this talk, but just to include for completeness. One is ocean thermal, which the US had a program that looked at, that built a couple of demonstration projects, but I think was closed down in 1999. And this is about harnessing the temperature difference between different depths of the ocean, cold water in deep water, and warmer water at the surface heated by the sun, and really utilizing that temperature difference. And what you see on the right there is a sort of reverse refrigerator, where you're using that cold energy to effectively drive a turbine in a closed circuit with ammonia. And then finally, another kind of oddball one is osmotic energy. And this is really energy that arises from the mixing of fresh water and salt water together. And you can build up an osmotic pressure through a membrane, which apparently can drive quite a lot of energy. But I'd say, you could also say probably that these are ranked in order of activity. Offshore wind energy is where the commercial money is at the moment, and where there's a lot of development going on. Wave and tidal are both at the same sort of level of development, and ocean thermal and osmotic energy are probably a little bit further behind in terms of current activity. I wanted to give you some examples of wave energy. Unfortunately, there's not really enough time to talk about these, but just to give you a kind of flavor of the different kind of concepts out there. what you've got here on the left is a shoreline machine. It's called an oscillating water column. Waves come into a kind of collector, crash into a collector, and drive air up through a turbine, which is uniquely designed to work in two directions. So as the air passes through the turbine blades as a result of the wave action, electricity is produced. The machine on the right there is the one from New Jersey. That's Ocean Power Technologies, which have a buoy-type system with an outer ring and an inner ring that goes up and down in relation to the waves. Here's another different type. This is the Archimedes wave swing, it's called. And that's rather a large structure. And that is floating there on the surface, but that structure is designed to lower the whole machine down to the bottom of the seabed, and actually sits on the seabed and has a kind of bubble of air in the top, in the dome, that allows this sort of central part to move up and down as the waves pass over the top. And the picture on the right-hand side is their new iteration of that type of technology. Another different type here at the bottom, this is called the Wave Dragon. This is a bit like a hydro project. Waves come over a barrier and then drain down through turbines that sit on this kind of artificial beach that's moored out there at the sea. Another one up the top there, this is called Ocean Links Australia. It used to be called Energy Tech. They changed the name. This again is another type of oscillating water column, but this time it's the machine is out at sea and moored out at sea. Another one here at the bottom, Fred Olsen. This is Fred Olsen is quite big in Norway in shipping and in the oil industry, and this is a system here which potentially has application on offshore oil and gas rigs. Then on to tidal energy, flow energy examples. This is a UK company here on the left, SMD. These turbines are moored, and when the tidal direction changes, the whole machine flips over and allows it to face into the direction of the flow, either way the flow goes. Another one here on the right, this is marine current turbines. This is installed in the southwest of England, and they're currently building another project in Northern Ireland. And what you can see here, very much like a wind turbine, except it's under the water. And because of the density of tidal energy, it means that you can have a much smaller machine for the same power output as a much larger wind turbine. What you're seeing here is that the machine is in its maintenance location. Normally, of course, the blades would be in the water, so they go up and down there on the machine. Another couple of different types, Verdant. They've got a project in the Hudson River in New York to harness the flow through the river, and I've been doing very well with that. Another machine at the bottom, Stingray. This is more of a hydrofoil that moves up and down with the flows. And then on the right, another US company with a project that they've now installed in Scotland called Open Hydro. And this has, you can't really see it there, but it has a kind of ring that moves around as the flow passes through it, rather than having a central axis. It has a hole in the middle and it's really just the outer part that moves.